Welcome back, everybody. Today's video is going to be a little different. I am going to attempt to repair one of my coworkers' model train effect circuit boards. It is by far the most challenging solder repair job I've ever done. A 3-watt audio amplifier died that happens to be in a 1.6mm BGA flip chip package, as you can see on the screen here. So that 500 micron pitch is going to be thrilling to try and do by hand. The way that this was confirmed to be the failure was via infrared inspection. You can see on the image here, it actually locally got so hot it saturated the camera, which I haven't seen happen before. So it was around 180°C, just running for a few seconds. You also see in the upper right, the voltage regulator is quite hot. Ideally, you'd want to do this in a reflow oven, but it is a double-sided board with some plastic connectors, as well as I don't have a reflow oven. So I'm going to see how well I can do just by hand with a hot air rework gun. And let's jump in and see how it goes. Take and wrap the board in some Kapton just to protect some of the outer chips so they don't move under the hot air, as well as to protect the board when I clamp it in my helping hands here. At which point I am going to start heating that board, a little bit of the bottom, a little bit of the top. I'm heating at 310°C, and I'm just going to start heating that whole area up. Unfortunately, that flip chip is rated for 3 watts, so there's a significant amount of heat sinking through those 9 pins, which is going to make this even more challenging. After I heat it up for a little bit, I'm now going to apply some flux paste on that. And I'm going to come back in with the hot air and the tweezers, and we're going to just wait for that chip to loosen up. And you'll see it actually flips up on its own here when those solder joints all melt free. Alright, the next step is we need to clean up that footprint. So there's going to be different height and amounts of solder left on each of those 9 pins. The BGA package already has solder balls applied, so you don't need any solder, you don't want any solder remaining on that footprint. So we're just going to again heat that up, and we're going to apply some flux paste to it and do our best with an oversized piece of solder wick to try and remove it. You'll see first here I'm trying to remove it with my soldering iron. Unfortunately, it really ends up not working well. I think a mix of a lack of flux simultaneously with that package being heat synced to the lower power pads just made that solder cool down enough it didn't work. So I decided I would try and hot air rework it, as you can see we're going to be doing here. All those pads became liquid, and you could visibly see the flux flow off and that the pads were fairly clean. So I called it good enough. Now that the package footprint is cleaned up, the next step is to try and reflow that part onto it. The challenge I already saw coming into this is the fact that that is a high power package and those pads are going to be heat sinked quite well. In order to pump enough heat into that board, I'm going to need to move a lot of air over it, and that package is just going to want to constantly fly away. And you can see here in the sped up footage, it just keeps, before anything's even reflowing, it's just blowing out of my tweezers. So I tried this for a little while, eventually ended up throwing out that part. Good news is I bought spares and grabbed a new one and decided to take a slightly different approach. Because at one point a couple of the balls did reflow, and then I didn't really trust putting that package on the board that it was going to be soldered and adhered properly. Now ideally I would have had a reflow oven, and I could have just put this board in there and tried to reflow this part on. I don't know how the connectors and stuff would have held up, but it might have been a better way to do it. Eventually I decided to try and take Kapton, since it is a high temperature tape. Unfortunately, you'll have saw earlier some smoke coming off the Kapton. While the Kapton's high temperature, the adhesive is acrylic on this specific tape I have. So that smoke is the acrylic adhesive burning up. I decided to just set that part where it belonged on the PCB board, lay a piece of Kapton over it that I stuck to the rear package behind it pretty well. And I thought after that board is kind of preheated, I can just drop that piece of Kapton tape down, let the part somewhat naturally sit there. The Kapton will hold it in place, and hopefully those balls will reflow underneath it. Now after it cools a little bit, I take that tape back off, and I do try and reflow it one more time. I just wanted to make sure that everything melted evenly. So you can see there, at this point, there's enough solder that the surface tension of the solder is holding the package in place. But what I didn't consider at the time is when I was pushing down, it's possible I was squishing those balls too much, and I might have squeezed some solder out and into places it doesn't belong. We'll have to see how this looks under a microscope, and also if it actually has continuity on all those pins, which we won't know until we actually try and power the system up. Then here you see me kind of trying to wipe some of that flux residue off. I ended up just dumping it in a cup of isopropyl alcohol and scrubbing it with a nylon brush. All right, here we have some pictures of the finished repair. You can judge for yourself. It's not perfect, but looking at these pictures under a stereoscope, it looks like all of the sides I can visibly see, there is bonding to the pads, and it's hard to tell. There's still some flux residue in there, but it doesn't look like there's any solder bridges. Everything looks relatively well rounded. A little tidbit on the side, if you're wondering how I got these super close-up images, it was just with my SLR camera and extension tubes on a normal 55-250 lens that allowed me to zoom in significantly more. Anyways, thanks for watching, you guys, and if you like this, leave a comment.